Hello all. Welcome to the PolyJet photopolymer aging study by group 11.1. The project sponsor was Los Alamos National Laboratories. Our company contact was Denver Smith, and our academic mentor was James Conrad.
Our group's problem statement was Los Alamos National Laboratory wanted an accelerated aging study done on a UV curable photopolymer to test geometry, mechanical properties, and color fading over time with exposure to UV light. Our group had 7 requirements. The first requirement was price, where everything must cost under $1,000, and to test that, we have a bill of materials. Second requirement was color, where the testing model must include color in order to study UV exposure effects on color quality. To verify this, we used a JavaScript application to compare the average RGB values across the exposed parts and the control samples. Third requirement is geometrical testing, which we were doing to see how UV exposure affects the dimensions of the part. To test this, we used dial calipers to measure the parts from the control over throughout the exposure process. The fourth requirement was size, where the product should at most be 490 by 390 by 200 millimeters. To test this, we had CAD drawings. Fifth requirement is tensile strength, just to test how the UV aging affects the tensile strength and modulus of elasticity of the parts. To test this, we did a tensile strength test and followed the ASTM standard D638-14. The sixth requirement was hardness, and we're just testing how the UV aging affects hardness. To test this, we had to follow the ASTM D785-08 Rockwell hardness test. Our seventh requirement was impact strength, to test how UV aging process affects the impact strength of the parts. For this, we had to test parts before and after the UV aging process, following the ASTM D256-10 ISOD impact pendulum test. And those are our 7 requirements.
For the tensile testing, the team followed ASTM standard D638. The tensile testing was performed on the dog bone specimens in Conoy Lab on the UTMs. 5 specimens from each group were tested until fracture, those groups being the control group and groups A, B, and C. The dimensions were recorded for every piece prior to the testing to ensure the calculations would be as accurate as possible. A stress strain plot was created for each of the groups following the testing. For the ISOD impact testing, the team followed the testing procedure from Section 10 of the ASTM D256 standard. Dimensions were recorded for each specimen before testing. The testing was done in Potter Lab using the cantilever beam ISOD type impact test. The tests were performed on the notch specimens we received from Los Alamos Labs that were printed on the Stratasys J750 printer. 5 specimens from each group were tested. Those groups again being the control group and the UV aged groups, groups A, B, and C.
For the hardness testing portion of the project, the team decided to use an HRM test. The team used the ends of the dog bones that were also used for the tensile test. This was chosen because it is a solid fill, there is no filler in the middle, and the ends also have enough space to perform 3 tests done to each end without having each hit affect the other. 3 hits were done on each of the 5 parts for a total of 15 data points for each batch that we will discuss later on. For the color testing portion of the project, the team took pictures of the 2 cubes that were in each batch. One of those cubes being a rainbow colored cube and the other being a multicolored cube of solid colors. Pictures were taken before and after each of the 3-week, 6-week, and 9-week batches on each side of the cube. Each side was labeled, so it was easy to tell which side was which. The pictures were taken with a GoPro camera and done in a light-controlled box for maximum consistency.
To check the dimensional stability of PolyJet 3D printed parts in response to UV exposure, specific dimensions were measured on 2 separate parts throughout the testing period. The tesseract was designed to have thin sections with large overhangs, while the warping specimen has a very thin, flowing shape in order to maximize the possibility of dimensional changes in response to UV exposure. Tesseracts are measured along the 4 sides of each face, as well as an additional center-to-center vertical dimension for a total of 20 recorded dimensions on each tesseract. The length and width of the warping specimen, along with the height of the curved and upswept sections, were measured for a total of 4 recorded dimensions. All measurements were taken using a pair of digital calipers and measured 3 times each and averaged. To ensure the testing environment inside the aging chamber remained constant and account for any temperature or humidity swings, the temperature and relative humidity inside the chamber were logged throughout the testing process. This was accomplished using an Arduino microcontroller with a data logging shield and a simple temperature and humidity sensor. Readings were taken every hour throughout the duration of testing, and the results can be seen in the temperature and humidity versus time plot. The temperature inside the aging chamber varied by 2.8 degrees Fahrenheit with an average of 81.3 degrees Fahrenheit, while the relative humidity varied by 14.8% and the average was 20.8%. The large humidity swings were likely caused by opening the aging chamber to rotate parts weekly or whenever we switched out the batches.
After determining what needed to be obtained from our samples, we decided it would be in our best interest to have 3 different groups exposed to UV light on a different timeline, and one group to be a control group to compare the other UV sample groups to. Since it would take the longest, the 9-week group was put in first along with the 6-week group. These samples were then rotated inside of our exposure box to ensure that we were equally spreading the UV light inside of the box to each of the samples, and no sample got more than any other samples. After the 6-week group ended, the 3-week group was put in place, allowing the 3-week group and the 9-week group to end at the same time and allowing us to get all of our testing done at the same time without having to take multiple visits to the labs.
Alright, now it's time for our mechanical testing results for our IZAD impact test, our HRM test, and our tensile test. For the results, comparing them to our initial control group, we found that the 3-week specimens actually performed significantly better than the control group during these tests. We found that this could be possibly true since the material is a UV curable photopolymer, thus being in the UV exposure box for the 3-week period of time could have given the material enough time to cure and increase the mechanical testing results, with this having a higher impact resistance, higher tensile strength, and increased hardness for that 3 weeks period. As for the 6 and 9 week batches, we started to see what we thought would happen, the degradation of the part. This gave us slight results from our control, nothing very much statistically to go off of as far as significance. In order to get a more drastic result as far as degradation, these parts would have to be in our UV curable box for a longer period of time than just the 9 weeks that we maxed out these specimens at. As far as our total results, we're very happy with being able to see how within that 3 weeks period of time we were able to actually cure the photopolymer slightly more and give it better mechanical results, and then see how it started to degrade over that 6 and 9 week period of time.
After each batch was done being exposed in the UV chamber, it was removed and the rainbow cubes were photographed in a controlled environment. The lighting in this environment was constant, as was the position of the cube and the position of the camera. These images were cropped and put through a program that analyzed the average color. The average RGB values of these images are displayed on these two charts. The first plot shows the percentage change from the original control pre-UV exposure values. As you can see, there is not a linear change based off of the weeks of exposure time. The reason for this is unknown, but is speculated to be due to the camera settings of the GoPro used in photography. When the values are zeroed at the blue, however, because blue is expected to have the least amount of fading, it's clearly shown that the red and the green decreased relative to the blue over time, with the red having the sharpest decrease. This is expected because red pigments absorb the higher energy ultraviolet and blue light while reflecting the lower energy red light. Absorbing these high energy light wavelengths cause the pigments to break down faster than other pigments of different colors.
At each stage of testing, the dimensions of the parts were measured 3 times and the average measurement was recorded in a spreadsheet. Looking at the data, there is very little change happening to the part dimensions. On the tesseracts, no single dimension changed more than 0.05 millimeters, and there was an average change of 0.02 millimeters. The warping specimens, which were far more difficult to measure consistently, had a maximum variation of 0.14 millimeters and an average variation of 0.05 millimeters. Due to the very small changes and lack of any upward or downward trend in the measurement data, we find it is unlikely UV exposure caused any dimensional changes in the test parts. Any changes seen in the recorded measurements were likely due to some type of measurement error due to the difficulty of measuring the thin, flexible parts.
And now wrapping up our presentation, overall our testing and experiment went about according to plan, what we fairly expected. Obviously in our mechanical testing, the 3-week specimens threw us for a little bit of a loop with actually curing the specimens slightly and giving us better mechanical properties as far as fading and degradation or changing the shape of the materials and the specimens. There wasn't very much significant changes there other than a slight variation in the red color samples. Overall, very slight and statistically almost insignificant results. However, the results did start to trend in the way that we had expected, and and upon further experimentation and a longer process of experimentation, we would expect to see more significant and substantial results with this experiment, giving us a very well-rounded and very obtainable goal for this experiment. Thank you for watching, and we've provided our emails below if you have any further questions. Thank you very much.